Avoider game, part 2. We will continue from the last part. We will now code all the functions for the baddie and the baddie type. Let's see, we loaded the baddie's image. Now we'll just have to do the logic. We already have the boilerplate code for everything, all the methods. Actually, we'll need one more method to create a baddie. We'll call it new baddie. So the baddie type will need a few more attributes. The speed, its direction x, you've seen they move in like many different directions, up, down, diagonally. Direction x and direction y. Let me explain this. This is like the movement vector, like it's x and y, its position vector, the baddie. Like the x and y will be stored on the AppGameKit sprite and be changed using set sprite position or get sprite position. This one is well, if you haven't learned vector math, it's very useful for game programming. I actually don't have a formal education in math. I learned it as I programmed games, so yeah, you don't really need to worry about the theory or stuff. So as I said, the position vector is the x and y of the sprite, the baddie sprite, and its movement vector is the direction x and y. It will be added to the movement vector and multiplied by the speed and added to the movement vector. Let's say it moves 1 on the x direction, so 1 multiplied by speed, and you need to add it to the current x. So let's say speed is 5 multiplied by 1, so it will move by 5 pixels. If direction is 0, it will move by 0, because 5 multiplied by 0 is 0, minus 1, it will move to the other direction. Let me show it to you in Paint. So 0, 0 starts here at the top left, unlike the traditional here, the way they show it to you in math. So on the screen it starts from this place. Let's say this is our baddie. And so from here on the x-axis this is 1, 2, 3, whatever. So if the direction is 1 multiplied by 5, it will move by 5. So 1 will make it move right. And if the direction x is minus 1, it will move minus 5 to the other direction. If the direction x is direction y is 1, it will move down. If it's minus 1 multiplied by speed, it will move up. If the direction x is minus 1 and the direction y is 1, it will move like this, to the left and down. And if the direction x was 1, direction y is also 1, it will move to this place. Say if it reminds you of something, if you remember the Pong tutorial, it also uses vector addition. You add one vector to the other. But again, doesn't matter as long as you understand this. So this direction is direction y minus 1, direction x 1. Is it correct? Yeah. And this direction is direction y minus 1 and direction x minus 1. Yeah. That's direction x minus 1, direction y 1. Yeah. And that's how you move an object without involving angles or anything. Well, actually it's radians rather than degrees. Again, you don't really need the theory to use it. I just wanted to show you this. It's not necessary. I will need to make a dedicated tutorial for math and game programming, but in the meantime follow me. This way is the easiest way for me to do this. Like instead of 100 ifs, like if move up, if move left, if move diagonally, blah blah blah. So the new body will get its starting x position float, which we will set to the sprite we'll create for the body, and y as float. What else? It will need speed. Actually no, I'll make the speed random, so only x and y. So new baddie, it's an int, it will hold the ID of the new baddie. Yeah, so its ID will be sprite counter Did I write it correctly? So yeah, after that we'll increment the sprite counter, so when next time when you add a new body or something else, it won't clash with an existing ID. So at first it will be 2, as you can see. The sprite counter will start at 2, as 1 is reserved for player sprite. Let's see. Where were we? Yeah. New baddie ID. And we'll create the baddie itself, be as yBaddie. b.id will be nb. Its speed will be random. One to 4. I don't want it to be too fast. Let's see. b.dirx will also be random. Sadly, I don't have a way to start it from -1 to 1. Maybe it can be done with AGK. I don't know of this feature at the moment, so I only know you can do random with positive numbers, 0 and positive numbers. We'll handle it in a moment. Dir y is the same thing, and we'll have to do another random check to check if it's -1. If dir x will be -1 or dir y will be -1. If random 1 to 10, like I'm doing it with percent. 1 is 10%, 10 is 100%, so 50% if it's bigger than 5, dir x will be -1. We'll do the same for dir y. So there's a chance, 50%. Well, yeah, it will be 0 or 1, and 50% it will be -1, both for dir x and dir y. So it can move to either direction on its when we add its movement vector multiplied by the speed, of course, which will be something random between 1 to 4. You'll see when I use it. Okay, now we'll need to create the sprite. its ID will be NB. Its IMG image will be the baddie IMG, which is 2. Let's see what else. We'll need to increment the sprite counter. So the next baddie will have a fresh new ID. Like if it's 2, it will be here, it will be 3 after we use it here and here. Next, we will actually set the sprite position. Which sprite? The new baddie, using its ID. Okay, its X will be X, and Y we get from here. Okay, let's see. And we'll need to add it to the baddie array. Where is it? This one. Because we want a way to manipulate all the baddies we add to the game. Once we get the yBaddie object, we can manipulate its ID, its sprite using the ID. Like if we want to set its position, we'll just call the baddie ID b.id or whatever. So for that, if we want to have an easy way to manipulate the baddies, we will put them in a baddie array. We would have done the same if we had like bullets or any other type of object. In my framework, they're all Y entities. It's a very flexible object. But because we're not using any structure, yeah, we'll have to put it on an array. Let's see now. Spawn baddie. Okay, let's spawn a baddie. So when the timer is done, if random from 1 to 10 is bigger than 5, 50%, then add a new baddie. And new baddie, random, its X will be random 0 to 50. So basically it will spawn anywhere like here. Its Y will be, its random for Y will be like all of the string length, and if it's like smaller than 5, like the else over if, it will spawn all the way here. So like it moves in different directions and wraps back here. You'll see it. Let me finish code it and I'll explain it again. So basically what this does is, as I said, spawn a baddie anywhere in this area, anywhere here, and in the else we'll spawn one here. So that way they move like from these directions. We'll have these variations. If you have a better idea, like do whatever. I don't want to spawn them like anywhere here because the player can move here, so I only spawn them at the edges. Like if the player is here and you spawn a baddie on top of him, he loses automatically when they touch him. So I spawn them only at the edges. Let's see. Else and if. So let's copy this one. We'll just do that. Okay, so it will spawn a baddie, reset the timer, and wait for the timer to proc again. Let's see it. Yeah, see? Okay. Oh, here, one spawned on this steps. Like they can only spawn here or here. When they move, it doesn't matter. Like it won't affect the gameplay. Let's see what else. So now we spawn them. Now we wanna do the movements. So we'll have to loop all the baddies in the array for I equals 0 to the baddie array length. Where's the baddie array? Here it is. If you remember, the baddie array is this thing we declare here. It's a global array holding all the baddie objects, baddie types, which is an object, struct, whatever. So let's get the ID of the sprite of the baddie we want to manipulate. It will be yBaddie array at the position of I, that's the current baddie, and we'll get its ID. And we'll get its speed too. I don't put this on a variable because it will create a copy of whatever is in that position in the array. I want to manipulate the actual baddie type that's in the array. What it returns is actually a reference, which is to you know, it's the actual baddie I want to manipulate in the memory. Okay, direction x, dx equals not dx, dirx, and the same for direction y. I'm just putting them on variables so it will be easier to work with. So we need the sprites x. We'll do get sprite x bid. We'll need that because we'll need to add to it dx multiplied by speed. We'll see in a moment. Same for y. And finally we'll have to do everything. Set the position, set sprite position, so which sprite, bid, and x, it's x plus in parentheses because we want to do this operation first. What was it? Speed multiplied by the movement vector dx, and for y it's the same, plus speed multiplied by dy. Okay, let's see what this does. Okay, I don't want to wait. Let's copy this and just drop it here a couple of times. Okay, they move in random directions. And this one has its dx and dy to 0, that's why it doesn't move. Same with this one. Yep. And yeah, I don't want them to go off screen and never return, so let's do the wrap for now, and I think we'll have a part 3. So we'll need this loop again to loop all the baddies, to check their boundaries, like if they're off screen, make them wrap to the other side of the screen. Let's say it goes here, it will come back from here. It goes here, it will come back from here. It goes here, it will come back from here. That's what we're implementing now. Okay, let's see. We'll need some of these. Actually, I'll only need the x and y. So, if x is bigger than get boundary right, here it is, then x equals 0. So basically this one is this is the boundary right, meaning if our x is bigger than the boundary right, make it equal 0, bring it back here. Okay, and let's do the set position, just so don't forget it. No need for these, we just want to set the x and y to the new x and y. So in the other cases, if x is smaller than the left boundary, here we want to make it equal to the right boundary. Let's copy this first, and we'll drop it here. Smaller than left. And let's see, for the y it will be if y is bigger than get boundary bottom. Then y will be 0. And if the y is bigger than the top, then it goes to the bottom, wraps to the bottom, I mean. Let's see if this is right. It should be bigger than bottom. I have experience with those things when I get confused and do mistakes, so I instinctively know what to look for. Let's see, this should work. Boundary top bottom means this is boundary top, this is boundary bottom. Take a look at it, you'll understand it. Oh, there it is. Now it will come back for me. Oh, it came back. This one goes here, should come back here. Okay, I think it works. Nope, it worked from there to here. This one will work from the bottom. Okay, it seems like it works. Let's see this one. When it reaches the bottom, it should come back here. Yep, here it is. Oh. This one will come back from somewhere. Yeah, it's hard to follow them, but it seems to work. Well, I'll stop now and I'll tell you we have two things to do. In the movement after this, we'll need to make it change direction with modulus every 500 points, and we'll have to implement this method when the player collides the baddie. If you have any questions, please contact me via the comments or any way you can get me, the AppGameKit forum, my contact form, whatever. Just contact me if you need help. And that's it for this lesson.